Lesson 8.5, solving quadratic equations by graphing. After spring break, we're going to be learning several other methods for solving quadratic equations, but the first method we're learning today is by graphing. Okay. It says every quadratic function has a related quadratic equation. Okay, well, what is a quadratic equation? A quadratic equation is an equation that can be written in standard form as ax squared plus bx plus c equals 0. Okay, remember it says every quadratic function has a related quadratic equation. So here, they want us to write this quadratic function. It's a function because we have y equals. They want us to write y equals ax squared plus bx plus c as a quadratic equation. Well, you can see in the equation it's set equal to 0. Therefore, our quadratic function has to be set equal to 0. In other words, I want my y to be 0. So we're going to have 0 equals ax squared plus bx plus c. Or you can write it as ax squared plus bx plus c equals 0. Either way, it's the same thing. So if you have a function and you want to set it as a quadratic equation, you're just going to set it equal to 0. And you just need to remember that y needs to equal 0. Okay, there's 3 steps that we use in order to solve quadratic equations by graphing. Okay, and here's the 3 steps. Step 1 is to write the related function. If it gives you an equation, write it as a function so you can graph it. Step 2, graph the related function. Okay, you're going to graph it on a coordinate plane. That means you need to have some points. Graph it. Step 3, find the zeros of the function. Remember, zeros of the function is where it crosses the x-axis. Okay. For example, here would be your zeros of the function. Okay. Remember, for it to be zeros of the function, your y has to equal 0. Okay. That's all a reminder from a previous lesson when we were talking about zeros of the function. Okay, so example 1. Solve quadratic equation by graphing. Okay, they give us 2x squared minus 2 equals 0. We want to solve this by graphing, therefore we have to write it as a function. So instead of 0, I'm going to put a y there. So I'm going to have 2x squared minus 2 equals y. The way we're used to seeing it is y equals 2x squared minus 2. We just flip it. Okay, now we have a function that we can graph. So, you already know what I'm going to tell you. I'm going to tell you to graph it on your calculator. And once you do, I want you to bring up your table and give me some points that we can graph. Hold on just a minute, I'm fixing my calculator. Okay, y equals 2x squared minus 2. And then we're going to bring up our table, second graph. Now I'm going to give you some points to graph. I'm going to use the points x equals -1, x equals 0, and x equals +1. When x is -1, y is 0. When x is 0, y is -2. And when x is 1, y is 0. So from here, we're just going to plot those points. -1, 0. 0, -2. 1, 0. Draw your parabola. Okay. The solution. is you want to find the zeros. Find the zeros of the function. Okay, so let's find those zeros of the function. Remember, we want our y to be 0. And for our y to be 0, it has to be on the x-axis. So I can see that my zeros are at +1 and at -1. Let's see that. Okay? Those are my zeros. So the solution to this quadratic equation is going to be -1 and +1. Okay? How are we going to check that? Well, we could plug it back into our equation. We could say, if x is -1, we could say 2 times -1 squared minus 2. Does that equal 0? It's going to leave me with 2 times 1 minus 2. Yes, that does equal 0. So this is a correct solution. Now let's plug in +1. 2 times 1 squared minus 2. Does that equal 0? That leaves me with 2 times 1 minus 2, which also equals 0. So both of these are correct solutions. You can also, to check, look at your table. Remember, you wanted your y to be 0? We wanted our y to be 0. Look at your table. Y is 0 when x is -1. Y is 0 when x is +1. So these are your two solutions. Okay, let's do B. I have -x squared minus 4x minus 4 equals 0. To solve this by graphing, we want to write it as a function. That means plug in y for 0. Or we would look at it as y equals -x squared minus 4x minus 4. I still want my y to be 0. That's where the solution is. So if I graph and if you're following along on your app, the notes on your app, it's going to show you how to do this particular problem because we're going to use a new feature of the calculator that we haven't used to this point. Okay, we're going to graph -x squared minus 4x minus 4, and I'm going to bring up a table. I'm going to say when x is -4, -3, -2, -1, and 0. Okay, when x is -4, y is -4, -3, -1, -2, 0, -1, -1, 0, -4. Alright, so from here we have some points, so we just plot those points. -4, -4, -3, -1, -2, 0, -1, -1, and 0, -4. Here's our parabola. Find the zeros. That's how you're going to find the solution. Find the zeros of the function. In other words, where does y equal 0? If I look at my table, the only place that y equals 0 is at -2. Well, look at your graph. Is that the only place it crosses the x-axis? Yes, at -2. So the only solution to this graph is -2. Okay. Grab my iPad right quick for this. This is going to be example 2 on your app. Chapter 8, lesson 5. Okay, example 2, talking about dolphins. At the beginning of this lesson, It says who uses this? I mean, because y'all ask me every day, why, Miss Franklin, when are we ever going to use this? Well, it says that dolphin trainers can use solutions of quadratic equations to plan the choreography of their shows. I'm sure most of y'all have been to SeaWorld and have seen the dolphin show where they all jump out of the water and it looks to be in sync, and you're wondering, how did they plan that? Well, this is how they planned it. They used quadratic equations, the solution to a quadratic equation. So if you're looking at example 2, it says a dolphin jumps out of the water. The quadratic function y equals negative 16x squared plus 20x models the dolphin's height above the water after x seconds. So x is our seconds. How long is the dolphin out of the water? Okay, well, when the dolphin leaves the water, its height is 0. Okay, so let's think about our x-axis. Let's say that's the seconds. And here is going to be the height of the dolphin. Okay? At 0 seconds, you know the height is at 0 as well. If he hasn't left the water, his height is going to be 0. Well, then this dolphin jumps. It jumps in the air and it eventually falls back down into the water. So we're trying to find out how long this dolphin is in the air. So how long does it take him to land back in the water? Well, that's where our function comes in handy. Okay? We want to know, when does our height equal 0? Okay? So we're going to graph our function. Try to do this where you can see it. Our function is negative 16x squared plus 20x. Okay, and I'm going to graph it. Okay, we get this parabola, this very narrow parabola. This tells me that this dolphin's not in the air for very long. And if I want to find when he reaches water again, because he starts at the water right here at 0, 0, he jumps and he lands at the water back right here. Well, to me it looks to be a little between 1 and 2 seconds. Okay? But how can I actually find this without guessing? Well, I'm going to use the trace feature. And everybody sees trace right here. Okay? We're going to move our arrow over until where our y is 0. Okay. Well, I know it's between 1 because at 1.06 seconds that dolphin is still 3 feet in the air. I can see that on my X and my Y. I'll move it over a little bit. At 1.27, it is now negative 0.5 feet under the water. So it's going to be somewhere between 1.06 and 1.27. And it's going to be closer to the 1.27 mark. So I'm going to roughly estimate that it's going to take 1.25 seconds. Okay. We could zoom in and we could set our window. I mean, I want my x min to be 0, because if I'm talking about 0 seconds, I can't have negative seconds. So I'm going to set my min to 0. I'll do max 10 seconds, count by ones. My y min, my height can only be as little as 0 feet. Y max, I'm going to leave it 10 and counting by ones. Let's graph it. Now we can see the graph a little better. So this time if we hit trace, I want my y to be 0. This time I can see when x is 1.17, my height is 1.49. If I move it over some more, at 1.27, my height is negative 0.5. So it's even between these two measurements here. Okay, so anyway, that's how you're going to find how many seconds that dolphin was in the air.